Hey guys, welcome back for chapter 2 of the Hover Control Bell 412 for FSX. And for chapter 2, we are going to look over the same things we did last time, looking at the using the same criteria. And we're going to start with just looking at the instrument panel. If you haven't seen the first video, this is a old model. When I say old, I mean really old. And it kind of shows its age here. So when we're looking at the model, a lot of things you see here just kind of painted on. So like the fire handles here are painted on. There's some 3D around the instruments. Now the general layout, however, that is accurate. So you have your engine stacks here for engines 1 and 2. Your triple tack, your torque for mast and engine is fine. You don't have great functionality for your Horizon and your CDI or HSI, however what we're calling, I guess it's CDI. So we can't actually interact with these, but the layout is fine, and we can interact. We just can't interact with them on the panel, and I'll show you that in a few minutes. So most of the things here, matter of fact, all of them, none of the switches are really. Where's my mouse here? None of them are really clickable. So it's modeled, but it's not usable. So that kind of shows its age here because in modern home use sims we can interact with all those things. But here everything is just either just modeled just to be modeled, or it's just painted on. So you can see here all the circuit breakers are just painted on. They're just textures. The lighting, it's accurate. So I won't knock them for that. It is accurate, but they're all painted on. So can't knock them for the accuracy. It's just not as detailed as it was. So uh, we can call that accurate. So, but for the buttons and animations, there really are none that we can use. And I'm using both my VR hand controller here in Fly Inside, and also with the mouse. None of this stuff you can actually interact with while you're in this 3D space, and that's not just because I'm in VR. Um, that's just the way it is. So, uh, and you can also I'm moving my throttle on my ProFlight trainer, and the throttle isn't really moving. So points for accuracy, because it looks like a Bell 412. As a matter of fact, it looks like this panel was taken from a photograph and superimposed over the 3D model. Um, and but we just can't interact with anything inside the 3D space, which is kind of a drag, especially nowadays. But back in the Microsoft Flight Simulator 2004 Century of Flight days, this was the pinnacle of freeware. So it's a product of its time, and doesn't really hold up well nowadays. So for button and features and animations, can't really get. I mean, the only things that are really animated are the flight controls. Um, so there's that. I think, do the doors open? Nope, doors don't open. The door's probably open with the open door command, but that's about it. All right, so readability of the instruments, um, they they all are perfectly fine. Now, since my last video, uh, actually there's a difference between the first half of chapter 1 and the second half of chapter 1. So I had upgraded my VR headset. So I left the Oculus Rift CV1, and now I'm talking to you through the Oculus Rift S, which is a lot clearer, which makes a difference if you're going to use this model in VR, for me at least. So what I'm going to call, some guys are going to argue, what I'm going to call the second gen commercially available VR headsets work fine with this model. So my Rift S, I can read everything clearly, and on the 2D panel, it's even easier. On the 2D monitor, it's even easier. So everything's readable, especially on the pilot side. I can even glance over on the co-pilot side. and I can read the airspeed indicator relatively easily. So that's good. So we can give them the full 2 points for readability. So for other views, this model doesn't come with anything else other than what comes stock with uh, Flight Simulator. I'm not going to go through the views because I'm going to try to stay in VR as much as I can for this, just mostly so I can point things out to you guys. But there's really no other special views to judge. Now let's start it. Okay, so we are at Santa Monica, same place that I did the chapter 2 in the X-Plane X-Trident version, and we are going to start this aircraft, or start this model rather. And I'm using the same checklist I did last time. This is the Bell 412 manual version, revision 4. It's the only one I can get my hands on. But we're going to, this is the same one we used to start the X-Trident Bell 412. So we're going to see if it works for this one. Now, you can tell that I got an outside view of this model. And we did that on purpose because, as you saw for the first part of this video, none of the switches are interactive in the 3D environment. So we're going to do this in 2D. And to get those switches, we have to bring up the panels. So the panels we're using are going to be the instrument panel here. And then we're going to bring up the collective, the upper console, the upper switch panel, the overhead switch panel rather, and the center pedestal are the ones we are going to use. So let's organize these real quick. Gonna bring that one over so we can see it. And then we're gonna bring the collective over here. Okay, so a couple of things. One, this is pretty much the only way to interact with most of these switches. And even then, some of these are just painted on. So like the comm panels here, these are all painted on. So it's hard to interact with these. So it's let me get this. So we're going to find, I think, throughout the startup that some of these switches that are mentioned in the checklist we can't actually interact with. But they are present, but only cosmetically. They're just painted on as textures for each of these panels. Okay, so let's get started. We're going to so on my Bell 412 checklist, revision 4, we're going to start on page 2-8. We're going to skip a bunch of stuff, so like seat belts, nope. Shoulder harness, nope. Flight controls, check. Actually, I'm going to look at the collective. Collective is full down. It's good. And one thing I noticed, and you can probably hear, is that it sounds like there's an engine running. So we pan around real quick. I notice we're really the only aircraft on the ramp. It's kind of hard to see with those panels in the way. So it sounds like there's an APU, and that is one unrealistic because the 412 doesn't have an APU. So we're going to go ahead and turn the sound off so we don't have to listen to that just for a moment until we actually get engines running. All right, so that'll help keep this from being super annoying. Okay, so flight controls we already checked. Collective switches, looking at the collective switches, they are all off. Okay, lower pedestal circuit breakers, not going to worry about. Radio equipment is all off. Compass control, not worried about. Fuel intercom switch. All right, so looking at the fuel panel here, the fuel intercom switch should be in the norm position, and it is. Fuel transfer switches, fuel transfers off and off, looking good. Boost pump switches, both of them are off. All right, good. All right, engine 1 and engine 2 fuel valve switches are both off, and particle separator switches both norm. So we're going to click those up to norm. Looks good. All right, and governor switches both to norm. So these look like they're painted on because there's no little hand. So see here, there's a hand, that means we can use it. There's no hand, means we can't. So those are going to be, can't interact with those. So that's one thing we can't do as per the checklist. We'll keep that in mind. All right, and hydraulic switches 1 and 2 on. Okay, changing the page here. All right, force trim switch on, cover down. So there's a force trim switch. It's painted on. You can't interact with that. Instrument static check, not worried about. Static source, nope. Approach plate and light map lights, nope. Aux pitot switch, not worried about. Altimeter, not worried about. Clock, no thank you. Fire extinguisher switch off, not worried about that. Fire handles, we can see that those are painted on. They're painted on in the 3D environment as well. All right, emergency light switch, not worried about that. Overhead circuit breakers, all painted on. We saw that. And it's not even an option here. So when we pull up the overhead panel, it only gives us these two. So we can't interact with all the circuit breakers. So we'll assume they're all in because they're painted on in. All right, rheostats off, utility lights, not worried about those. Position lights are off, and anti-collision lights are going to come on. And we don't have any battery power, so we can see that there's no lights on right now, so that's a good sign. All right, emergency load switch, that is painted on, so we can't interact with that. I'll keep that in mind. Essential bus switch, spring loaded, so essential bus switch, it is on, but it's also painted on, so that's something we can't interact with. So that's another thing to take note of. All right, so inverter 1 and 2, they are off, and Gen 1 and 2, they are off. Okay, so that's most of the pre-start checklist. We're going to start getting this thing applying power now. So battery bus 1 and 2, we'll bring those on. And notice that when we click that, it brings them both on at the same time. As soon as we did that, we got a fuel quantity. Oh, look at that. We need fuel. And actually, I had taken the fuel out so we could actually because the thing powers on. When you load it, it powers on. And there's like a way you can trick it into believing that it's into creating a flight for cold and dark, but you have to do like a bunch of save flight nonsense, and I just take the fuel out. So there we go. All right, now we got fuel. We should have fuel. Oh, come on. That's the number you're asking for here. FSX, come on, work with me here. All right, so now we have fuel. Oh, goodness. Let's do just 1,000 pounds. Okay, now we got fuel. All right. So now we got a fuel quantity showing. That looks good. Where were we? All right, so we got the 1 and 2 battery buses on. So now what we should see is some warning and caution lights, but we don't have those, which we already took note of in chapter 1 of this video series. But we're going to hit the press test and look at that. Okay, so we have warning caution lights, and these illuminate for some reason, so that's cool. But they don't actually illuminate when a system fails or we have an engine failure. We should have some caution lights illuminated right now because some systems are off. And part of the checklist is checking to make sure those lights go off as each of these systems are brought online. So another thing to keep note of when we're scoring this. All right. So moving on, I'm going to change my page on my checklist. All right. And we don't have any master cautions on, so hitting the reset's not something we can do. So we'll keep that in mind. All right, fuel system digital test button press. Oops, we're going to start. I skipped a couple steps. Okay, so fuel system test. So this is actually, oh, here we go. So that works. So we should be looking at this gauge here. So we're going to check the quantity in the forward tank. All right, we're seeing a difference here, and we got 96. I'm not sure if that's pounds or gallons. I want to say it's pounds. If that's pounds, that's kind of scary. That's really light. I think that's gallons. All right, and we're going to go to the aft. Okay, and we saw that quantity change. Yeah, I think that's gallons, not pounds. All right, good. And we're going to go back to the center. Yep, that's definitely pounds because I added 1,000 pounds of gas. All right, so that works. That's actually pretty cool. Moving on. So we tested that. And now inverter 1 and 2 switches on. So we're going up to overhead panel, inverter 1 and inverter 2. Looks good. And where you got, all right, so we're at engine starting. A couple of notes here. RPM, increase, decrease switch, decrease for 8 seconds. So looking at here, doesn't look, oh, here we go. So we're supposed to decrease this for 8 seconds. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll see if that made a difference. So we did that. Engine 1 start. All right, so fuel transfer switch on for engine 1. There we go. Boost pump, fuel boost pump on, and fuel switch on. Okay, so a couple of things. All right, we noticed we got fuel pressure, which we're supposed to look for. So that looks good. So fuel pressure check. Another thing I noticed, which is kind of weird, our throttle for engine 1 went to 100%. That's kind of weird. I'm not sure why I did that. I think it's probably some sort of coding thing. So remember, FSX doesn't do twin engine helicopters very well, so that may be something they had to do for coding. But if it's already at 100%, that's going to change our startup procedure for later. So we'll see how that affects everything. All right, so we got fuel on, rotors clear. All right, engine start switch. We're going to go to number 1. So look back on the collective, and the collective, I just have the collective menu over here because just keep it in close to the proximity where the collective actually is. So just I didn't want to confuse anybody thinking that was part of the center console. All right, so bring that back over here, and we're going to go engine 1 to start. There we go. All right, so we got a rise in N1, and at 12%, we should be opening the throttle, but the throttle's already opened. So that's not helping, but we're watching the ITT rise. That's cool. Rotors are spinning really, really quickly. So rotor RPM's climbing. Watching this, we got to make sure we don't go over 1090 and no more than 960 degrees for no more than 2 seconds for that. So we got a nice rise in that. Rotor RPM and engine 1 are already married up and rising together. All right, so that's stabilized. That's a little high for some reason. But engine oil pressure looks good. And looks like we have a good start on engine 1. So this automatically went back to center, which isn't actually realistic. It's not a momentary switch on the actual collective. I don't think anyway. And the reason I say that is because a little bit further into the checklist, it actually tells you to bring the start switch to off. So this one did it automatically. All right, so we got a good start on engine 1, engine transmission and gearbox oil pressures. Not getting any oil pressure here. That's interesting. And I lost my battery. So it looks like we lost electrical power for some reason, probably because the generators are off. So we'll keep going with the checklist and see what happens. All right, so we're supposed to check that particle separator, but I don't think, because we're supposed to check to make sure the light goes off, but I don't think we're not going to get that. All right, so moving on. All right, so in this point, we would be bringing the throttle to 77 to 85%, but we can't do that because it went to 100% automatically on us. All right, generator 1 switch will be coming on. There we go. And we got our indications back. So that's kind of weird. I guess the battery died. So I guess the battery isn't very strong on this one. All right, let's look. Keep moving. All right, so more extinguishing lights that we're supposed to see, which we don't see. Checking the amperage. Okay, amperage looks good. And engine 1 fuel transfer switch. And excuse me, we're going to start engine 2. So engine 2 fuel transfer switch coming to on. And then boost pump coming on. And then again, watch this. This is probably going to go to 100% once I do this. Yep, sure did. All right, but we did get fuel pressure, so that's good. All right, and now we're going to go ahead and start engine 2. So we're going to go back to the collective, starting engine 2. Not getting anything for engine 2. What are we missing? We got fuel going, particle separator's on, and go on. That's already on for some reason. There we go. Maybe I didn't click it right. All right, so we got a rise in N1 on engine 2. There's light off. ITT is rising. That shot up right away. That's kind of weird. That doesn't look right. So that married up almost immediately, even as ITT is still rising. So that wasn't very realistic. And again, we have N1 just pressed up against the top of the green arc into the bottom of the red. That's weird. Oil pressure high during engine start, that's actually not uncommon. But that should come down a little bit. All right, let's move on. All right, so we checked our oil pressure, and this point we already established that we can't open the throttle at 12% N1 because this goes to 100% automatically. All right, so Gen particle separator, we can't check those lights because we don't have any Gen 2 switch coming on. And that automatically adjusted the battery buses for us because we were getting generator power. We're not using external power, so we'll skip that step. All right, and checking amperage for both. We're looking good. And we'll be turning the radios on as required, which this isn't really part of the checklist that I'm worried about. But it's fun to click stuff. Okay. Okay, looking good. And EOT, no big deal, because if we crash, I'll just get up and go to the kitchen and get myself something to eat. All right, so that is an engine start. We'll bring sound a little bit. There we go. Nice sounds. So for the most part, yes, we can start it using a real-world checklist, but there's a couple of key differences in the procedures and how we do that. Mostly here with the collective. And there's a couple of switches that are on the checklist that we can't mess with, like the governor and the the warning and caution panel. Those lights don't illuminate when they're supposed to. And we have some weird electrical issues, weak battery, which, okay, that might be an FSXism. I don't know. So we can use the checklist, but we can't complete everything. And there's some weird behaviors, especially with the throttle. So you're not actually doing the full startup procedure with this. So I can't give full points for that. That's because we're not actually going through the full switch. We can click most of the switches, but we can't do a complete startup, so can't give full points. Now let's talk about some emergencies. So I went through I'm going to talk about this a little bit more in depth a little later on, but I went through the manual, the operator's manual for the 412, and there really aren't any emergencies in that manual that I can actually really do with this model. So for example, some of the tail rotor failure ones, there's some electrical system ones that we can try, but even then that's not really I can't like do, for example, I can't do manual throttle. This model just simply doesn't support that, so I can't turn off the governors and do manual throttle operations like we can. So can't really give full points for that, and that's unfortunate. But we will be able to do some pretend like simulated fixed pitch stuff and we'll talk about hydraulic failures and other things like that later on. But as far as any specific failure modes that this model offers, there are none. So there isn't any special module or any plugin that goes along with this model that specifically offers some specific failure modes to train with. So could you use this to train emergency procedures in an actual 412? You cannot. And that's basically what I'm saying here. All right, so that being said, let's move on to some emergencies that we can simulate. So we're going to move on to section 3.2, and we are going to do some autos. Okay, so I know I said we were at Santa Barbara earlier. We were not. We were at Santa Monica. I typed in the wrong Santa, but we are at Santa Monica. Still 20 degrees Celsius outside. Aircraft weighs. I forgot what the aircraft weighs. But we're doing it at Santa Barbara because that's where we did the 412 exercise. 412, chapter 2 in the in X-plane. So we're doing the same thing in FSX. So what we're going to start off with is some hovering autos. So I'm going to bring the aircraft to a hover, and then I'm going to roll both engine 1 and 2 off via the twist grip on my Pro Flight Trainer, and we're going to check to see how it responds. So I'm expecting to see some yaw that I'd have to compensate for with the pedals, and maybe some drift that I'd have to compensate for with the cyclic. And I'm also looking at the tachometer here to see how quickly the rotor RPM decays and how well I can manage that rotor RPM as I try to cushion that landing from a hover. All right, so here we go. We're gonna pick the aircraft up. And again, we're struggling with that really sloppy, large movement cyclic here, but that's all right. All right, so come up just a little bit more. All right, there we go. This is a good hover height. All right, and then we're going to roll the throttle out, keeping an eye on our triple tack. All right, 1, 2, 3. Throttle's coming off, and we just kind of sank as both the rotor RPM and the 2 and 2 needles stayed married. So the triple cat, there was no real split. I think we already knew that already because we did hovering autos last time. So one thing, I didn't notice any real, like my pedals stayed the same. So let's do another one, and we're gonna keep an eye on the pedals. Collective input wasn't too bad, but I did expect to jam some pedal in there to keep the nose straight, but the pedals kind of just stayed the same. So nice stable hover here, and we're gonna come up a little higher, just so we can see, give us a little bit more time to judge and look at what we're looking at here, and to interpret these instruments. All right, and here we go. Throttle's rolling off. Nope. And that hit kind of hard. So the nose did yaw to the right because I was at a habit from doing so many hovering autos. Automatically, I instinctively kind of pushed right pedal in there. That's what that right yaw was for. But really, that right pedal, in all reality, should have helped keep the nose straight, not turn it to the right. And I don't feel like I did too much. We'll do one more. Oops, sorry. Come on. This thing is really sensitive about the collective being up. As far as the triple tack goes. All right, so try one more. And this time I'm going to try not to compensate for forces that aren't there. Come up a little bit higher. All right, and 3, 2, 1. Okay, yep. Didn't mess with the pedals at all. And okay, now we're just kind of bunny hopping here. So no adverse yaw. Needle split's not all that realistic because it's not there. But the collective input's the same, so I won't give full points, but I'll give some points. But actually, I'm not even sure how many points I can give for it. I can give 2 points for hovering auto. I'll give him 1. I'll give it 1. I guess that's fair. All right, let's go. let's go do some straight in autos. So that was, we skipped ahead for the hover autos. That was section 3.2.2. Let's go do section 3.2.1 for the regular auto rotations. So one of the things that FSX models suffer from for autos is most FSX models tend to float like really, really badly, and FSX is not the only one. Like, there's some X-plane models that tend to float too, but FSX is like really bad. And also another thing that FSX models suffer from with regards to rotor RPM is, oh yeah, look, waves. I forgot FSX has waves on the coastline. Looking at you, X-plane. Anyway, one thing they suffer from is there seems to be a direct correlation between rotor RPM and airspeed, which is kind of unrealistic. So hopefully this model doesn't suffer from that, but we'll see. Well, we kind of already know that from chapter 1, but we're going to explore it in a little bit more detail. So we're going to line up on runway 33 right. Get us about, let's try 70 knots here for an entry speed. All right, we're nice and level, 70 knots. All right, throttle's getting rolled off. All right, so there was 0 yaw for both throttles getting chopped, so that's not very realistic. Rate of descent's actually not that bad, but I should need some right pedal to keep the aircraft in trim while we're in this auto-rotative descent. So if you look here, trim ball's perfectly centered, and I actually have a little bit of left pedal in. That's not very realistic. We're looking for some right pedal. Airspeed, looking okay. Come to the right here a little bit. So now we're going to see how this aircraft does in the flare. 60 knots, looking good. That's still enough energy to do a decel. So I'm going to start my deceleration. And cushion. That actually wasn't... Okay, that's weird. Okay. So my needles married up even with the throttle rolled off. So I couldn't actually do... Alright, that was weird. Alright, so throttle is rolled off, but if I try to roll the throttle on a little bit, rotor RPM droops. So it seems like there's a point where if it's at idle, the engines automatically go back to full. So that's kind of weird, and I think we knew that from chapter 1, but I had to pretend like I didn't. Okay, so let's do another one. And this time I'm not going to roll the throttle all the way off, because we knew that from chapter 1. So we're going to try it, and I'm just going to roll the throttle off to just until we get a needle split, and we'll try to put the 2N2 needles down at about 70%, just to make sure we keep that needle split all the way down and through the deceleration flare at the bottom, so we can actually do an auto. So it actually wasn't too bad until the engines decided they would insist that we not touch down, which that was kind of a... That was actually a little bit of a surprise, so we'll figure that out. All right, I'm going to shorten... Actually, I'm going to extend this downwind a little bit, because even though the rate of descent wasn't too bad, I'd expect to see a little bit more than that, maybe about 2,000 feet per minute, but that was okay. We are a little lighter than we usually are. You can see we only have about 620 pounds of gas on board. So I'm actually going to start my auto. I'm going to enter a little sooner than I did last time, since this aircraft, because we started right at the approach end of 3.3 and we floated all the way to the other end. So that's that float I was kind of talking about. So I'm going to go ahead and enter here. So I'm going to roll the throttle off just a little bit. The collector's going down. Oh. There we go. So there's a needle split. I'm adding a left pedal to get the aircraft in trim, which is kind of weird. So I'm kind of messing with the throttle to keep those needles split. So I'm still rolling it back, 60 knots, that's okay. I can take that. Rolling it back. Okay. It's at 70, so we'll take that. We have a good needle split, and it's already trying to marry again with the rotor RPM needle. Rotor RPM management is just fine. Oh, there we go. Now it's starting to descend. All right, starting my decel. and cushion. Not too bad. It was a little mushy at the bottom, and the rotor RPM really started to drag down as I slowed below 60 knots. So that's really that's odd, and that's part of that problem that most FSX helicopters suffer from, and unfortunately, this aircraft is no different. So I don't think we'll be handing out full points for the straight-in autos either. Next thing we're going to do is some tail rotor failure. So we can't do loss of thrust, unfortunately, because of the restrictions of FSX. But what we can do, not restrictions of FSX, but the restrictions of this model. So we can't do that one. What we can do is some fixed pitch stuff, and I can do that just by, and if you watch any of my other videos, I do that just by taking my feet off the pedals. So we're going to do fixed left pedal first. So this is typically done, you'll typically get this at a high power setting. So we have some left pedal in to compensate for all the power that we're pulling. So at this point, I'm going to take my feet off the pedals, and then we're going to see if we can't land. So the 412 manual says for a left pedal locked forward of neutral, reduce power, maintain engine RPM, and N2 within the green arc, and normal turns can be safely made, which we're doing. And under these conditions, and just the nose may be displaced. And on final approach, begin a slow deceleration so as to arrive at a point about 4 or 5 feet above the intended touchdown area, and effective translational lift is lost. And blah, 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 blah. Okay, so basically we're just going to shoot a normal approach. And we're going to shoot a normal approach to a 5-foot hover. And then we're going to apply collective pitch to stop the rate of turn, or rate of descent, and forward airspeed as we get to the intended landing area. So we're looking for near zero point of touchdown. We're going to give ourselves a little bit more space here. I climbed a little bit longer than I wanted to because I was reading. I was reading, but one thing I've already noticed is that there's very little correlation. So the pedals haven't moved. My feet are on the floor, but there's very little correlation between collective and the power applied. So actually, we're going to land on the far end of runway 25 here, just to give ourselves a little bit more space. And so we're not doing this big steep ass approach here. So we're going to go to that run-up area over there. So ready to sense. So I'm like pumping the collective here, right? And I should see some pretty drastic changes in heading, and I'm not seeing that. I'm seeing changes in the vertical speed, but not the heading. So that's one thing that's already unrealistic about this. But I think we kind of knew a lot of that before we got into this. So we're going to continue our approach. We're shooting for a 4 to 5 foot hover, and then we're just going to see if we can just put it down. And I have a feeling we will be. Now, what I am starting to notice is as we get slower, the nose is starting to want to follow the pedal. And I'm curious if I bring... So now it seems like the yaw might be a little bit more affected by the collective, but it's not a whole lot. Keep slowing down here. So far, this approach is looking pretty good. The nose is starting to want to go follow the pedal a little bit more. All right, there's our 4 to 5 foot hover. I'm going to bring in collective. All right. Now the nose should stop moving as I get to the collective setting in which the pedal failure occurred. Oh, well, I guess that would only be true if the pedal failure actually occurred in a hover. So that's not always true, but we've got a nice slow drift, and this would be perfectly safe to touch down at. And even time it so where you can touch down right on the center line of the taxiway here. So, is that super realistic? Maybe not. Maybe not. That seemed a lot less challenging than it should have been. So we'll try it again, but this time we're not going to try left pedal again. This time we're going to do a stuck pedal, a stuck right pedal. So as the manual would call it, stuck locked right of neutral. Now for right of neutral, the 412 manual says we should do a steep approach. So we're going to try that, which makes sense because you want to keep a higher power setting in. So here we go. There's our left pedal, or excuse me, right pedal. So we're going to leave the pedal like that. We're going to turn the aircraft around and go back to the same spot we just came from. Now in this case, we might need to adjust the throttle. So here I see so this seems a little bit more realistic here. Okay. So yeah, this is Okay. Huh. I'm gonna take that power out, see if I can't fly out of this. I don't think I can. You guys getting sick yet? I'm not. I'm good. Well, so that was interesting. So that got to the point where we couldn't recover it. Well, I mean, we got on the ground, but we probably would have rolled over with that one. So let's try that one again. This time I'll be a little less extreme with the right pedal. Sorry I let that go on so long. I just wanted to see how that was going to work out. So that was interesting. So let's try it again. So we're going to do this time we're going to do stuck right pedal. So right pedal, so we'll do equal amounts that we did for the left pedal. So that's about right, what we had for left pedal. And we'll start with our steep approach. Now, really what I should have done on that last one was start to roll the throttle back, because that would have brought the nose over to the left as we got a little lower. However, this model has some really strange behavior when you start messing with the throttle, with the collective up. So I kind of, okay, I'll admit it, I kind of wanted just to see what would happen if I didn't mess with the throttle at all. But see, in this case, as long as we have our airspeed up, we're fine with this side slip. So we're going to continue on with this steep approach, and this time I am going to mess with the throttle to help keep the nose straight. Now I don't want to do it too much since we're so high. That's not something you'd really want to do until you get a little lower. So that way, if you do end up having to chop the throttle, the consequences are a lot less. And I could have chopped the throttle at any time during that last one to stop that rotation. But again, I just wanted to see where that was going to go. So we're going to wait till we get a little bit lower before we start bringing that throttle off. So right now we're going to start bringing it off a little bit. Here we go. Bringing it down a little bit. Oh, and we tipped over. So that's That actually wasn't too bad. Well, I mean, I crashed, but the right up until me crashing, that's about what I would expect. I just need to manage the collective and the throttle a little easier. Now, part of that problem, we'll try it again. Part of the problem is with this model, it does strange things when you have the collective up and the throttle reduced. So we got away with it there, but let's see if both the model and myself can find some redemption here. So we're going to do one more with stuck right pedal. All right, pedal is stuck. I'm going to call that stuck on the right, stuck right. So feet are off the pedals, coming around. Yep, see, that's why I don't really like messing with the throttle on this one, because you see how the rotor RPM followed the throttle, which of course it would, because I've got a bunch of pitch in, because I'm doing a steep approach. But we'll see how this works. So as soon as, all right, I don't want the throttle to get past, the nose to get past 90. We're gonna tap. No, tap. Okay, that wasn't pretty, but we made it. Okay, so that was a little better. We still probably would have tipped over on that one. Let's try one more, and this time we're going to do a running landing. And I think this will go a little bit easier. So what we'll do is we'll take off from here. We'll do a straight out takeoff, just to the left of the tower, circle back around and make a landing to runway 7, and with a stuck right pedal, and we'll see if running a landing works better. And this is actually about as challenging as I think it should be. So that is runway 7, yeah? Yeah, it's runway 7. All right, so let's try that. Let's try that technique. All right, on climb out, I'm gonna kick us out of trim just a little bit. All right, we're gonna call that our stuck right pedal, and feet are off the pedals. And I'm gonna extend the down one just a little bit more. All right, now we're gonna start base to final. I'm gonna turn past the runway a little bit, so it'll take me a little while to get the runway alignment. We're gonna keep our speed up. There you go, there's runway 7. Probably gonna touch down right at the 1,000-foot marker there. There we go. Well, maybe a little. We might touch down a little bit longer than that. That's okay. We won't need the whole runway. All right. That's a bit fast. We're going to slow up just a little bit. There we go. So this seems a little bit easier. All right. Nose is starting to come around, so I'm going to roll the throttle off, bring the collective up. Ooh. That was much easier. Okay. So, yeah, that wasn't too bad. That wasn't too bad at all. So we'll call that one, we'll call stuck pedal. I'm not going to, right pedal performed a little better than the left pedal did, but, you know, I'll still give him points for that. That's not too bad. So yeah, we'll give him 1 point for that. All right. So for section 3.2.4, yeah. So here's the problem with that. There's not really much else I can check. So I know I can't do manual throttle because, as we saw during the startup portion of this video, the governor switches, I can't take these to manual, either on this panel or the 2D panel. Hydraulics. So hydraulics, this is another issue. Let's bring up the center console, which I think is Shift F8. Oh, there it is. Yep. So I'm going to turn, so, all right, oversight on my part, but you can see the hydraulics have been off the entire time. There's I tested this earlier. I'm going to turn them back on. There's really no difference between how the aircraft handles hydraulics on or hydraulics off. So I think that's just, in all honesty, just an animation. There's virtually no difference in controllability, um, hydraulics on or hydraulics off. So I can't really test that. And there is one other way we can do it. We can try it. Yeah, the model performs just fine, hydraulics on or hydraulics off. So there's one other way we can test a hydraulic failure, or try to test a hydraulic failure. And that is going to be through the FSX model, or through the FSX failures. So we're going to go to aircraft failures. I think it's under systems. Systems. Okay, so hydraulics. So okay, so let's try this. We're gonna fail all three, which I don't think this aircraft has 3 hydraulic pumps, but whatever. So you can see we got all 3 of them failed, right? So okay, getting back in the simulator. So ironically, the hydraulics are back on there. So they should be failed according to FSX. So bring the aircraft up. No change in controllability. I can do everything I've always been able to do. So I can't really test it. So there's no. So I guess that's just not available. So can't give points. 0 points. So you can see this thing is behaving just fine with the hydraulics disabled. So I tried it with the panel. I've tried it in FSX, and there's just no difference between how this model behaves with hydraulics on or with it off. Okay, so there's just no other way to test it, so I can't give any points for it. Okay, so moving on to the next section, as far as usability goes, for section, what is that, 3.3, overall usability of this model, to say that this model is extra usable, I wouldn't agree with that. Like it's entertaining if you're a FSX user. It's a nice model if you're an FSX user. It's free if you can find it, because Hover Control is gone now, unfortunately. But what would you be able to use this model to ease a transition into a real Bell 412? No. I can't say that you would be able to do that. For a lot of reasons. One, the fidelity of the model is just not there. Some of the systems modeling isn't really there and we've shown that today. Some of the things you are just painted on. It was, like I said earlier in chapter 1, it was a great model for its time, but as far as a training tool for someone looking to fly a Bell 412 in real life, I would not recommend this. As far as adjustable difficulty goes, there are no model-specific adjustable parameters like you would find in some of the X-Plane models. Basically, the only thing you have here is the adjustable difficulty in that's native to FSX. So I can turn down the control sensitivity in FSX. Not that I would want to make this cyclic any sloppier than it already is. As you can see, I'm stirring the pot pretty well there with very little consequence. So I can give this model a few points just for the native adjustability in FSX, but model specific, there is nothing that I can do in this model that I can't do with any other model in FSX to make it more to ease in its use, if that makes sense. So there's really no adjustable difficulty outside of the native FSX. All right, let's move on to the user manuals. So this is freeware, so it's not really uncommon for there not to be like a big, huge PDF style user manual, and especially when this thing was first released. Now this is, and you can see this is the FSX re-release, and this is the README file that comes with it. This is re-released in 2011, so it's 2019 now. So I mean, I give you some idea of how old this model is. And this is like this was like the latest version of it. So this model's been around a while. So it's it's kind of sparse, but it does explain a couple things. So like for example, this one thing I noticed in the README file, the generator. So that little weird electrical quirk that I had during startup earlier in the video, it actually kind of explains this, and it's actually a pretty weird quirk. Like you have to go into slew mode uh, after the first engine is running for some reason. Yeah, I guess that's kind of weird. So that's really weird for an engine start, but it explains that. Now, as far as any real details for like calibration settings or anything like that, it doesn't really have any of that, and that makes sense for its era, because back then when this model first debuted, there weren't a lot of special calibrations. I mean, freeware was freeware. I mean, if you go back even further, it was basically some variant of the Bell 206 that came with the simulator. They just tweaked it to behave differently and then called it a new model, right? So there's not really that much different about the model. So as far as like configuration goes, there weren't that many options, and there really still isn't in FSX. So it's not all that uncommon for it to be light on details for a freeware model, because there's not a lot of again, now there's not a lot of plugins to explain. I mean, so the only thing that really explained is this little weird generator quirk. So that's that. All right, for costs, this is probably the single most cost-effective model I've reviewed because it's free. NOS review I've done a video for is it's freeware. The only thing that it will cost you is some time to try and find it because Hover Control is gone. So I have no idea if anyone else, if any other websites are hosting this file, like maybe flightsim.com or maybe Simviation or something like that, may have a copy of it. I honestly don't know. And I mean, we snagged this copy before Hover Control disappeared. So as far as cost goes, yeah, full points for that because it's free. Performance impact, you will not have any problem with this model on a modern setup. So I'm running 50 something frames per second here, and that is on, and that's with like everything turned up. So if we look at display, it's like scenery. I mean, I'm running everything. Only thing I have is the level of detail cranked down. Shadows on everything. I mean, it's you get so there's no real frame rate impact on a modern system. So obviously full points for that. As far as libraries available, there's tons. So it already comes with just a wild assortment of libraries available, and I think there's a paint kit available for it too at one point in time. But even with just what comes out of the package, there's plenty to choose from. Um, so that's a plus. So there's plenty of those available. Checklist. Now let's look at the checklist. So there's none really available in the 3D environment. There's not a lot available in the 3D environment, and we saw that throughout both Chapter 1 and Chapter 2. But looking at the checklist, so I've got my Bell 412 actual checklist. Oh, well, this is not the checklist, but it's the operator's manual. And here's the checklist. Comes in a Word format uh, on this side. So I did spot a couple of differences um, in the checklist for the most part. So let's look at some of the differences that I found. Um, it's so in here they have for engine start they have these as steps, whereas in here it's more of a note. So for just rolling the throttle all the way to open, then back against idle stop, and then using the idle detent release to roll it back to full closed. Um, that is something I mean, like that's not really uncommon for helicopters of this era. Like when I was flying 500s and Jet Rangers, that's something I would do prior to each start. And in those aircraft, that was mostly just make sure you didn't mistake the idle stop for full closed. So you'd run it through its full, and that'll keep you from doing and run it through its full, hit the idle stop, and then physically roll it to the off position to verify that you weren't at the idle stop when you started. That prevents rumble starts and hot starts and things like that. It helps anyway. Um, so they have it here listed as steps, whereas here it's in one of the notes, right? And you're also checking, it's also a functional check of the idle stop to make sure it works prior to starting the engine. Because if your idle stop doesn't work and you start the engine and you need to shut the engine down real quick, that's not the time to figure out that your idle stop isn't working, right? So there's a couple of reasons for that. But other than that, they catch on a lot of the small details. So the RPM inker dinker, that's in there for 8 seconds. That's present here. The engine one start, that's pretty much a copy. It's abbreviated, which as far as flight sim, you know, FSX is concerned, it makes sense that you would abbreviate that. And notice they left out the caution lights on there, which is one of the things I was looking at when using the real checklist. Over here, we got the throttle open at 12%, throttle open at 12%. So things are marrying up pretty good. So ITT 960 max, yep, that's what we're looking for 2 seconds. They left out the 1090. They put the 2 second limit in here instead of the absolute max, which still not that's not really a deal breaker. Um, so they clearly followed the manual for these numbers. Um, so that's good. Moving forward, yep, N1 speed 61 plus or minus 1%, 61 plus or minus 1%. Yeah, so the numbers here jive and the steps here jive. It's just this is a really abbreviated version and kind of trimmed down for the capabilities of the flight sim. So they weeded out pretty much like a management by exception type thing where, yeah, if we can't duplicate it in here, we're just going to leave it out over here, right? Yeah, the checklist is pretty good. It's not exact, but it's pretty good. So we'll score them a bit higher on that. So for external views, you really don't have anything other than what's available in FSX. Um, so it's not that that's bad. It's just kind of boring, you know. It's like and when looking at the external model for its day, this was the absolute pinnacle, right? I mean, blades that move with the collective, feathering tail rotor blades, things like that. can you open panels and stuff like that? No, not really, but you got some sliding doors. Okay, that's cool. Um, but against modern standards, this one is really lacking, which makes sense because it's an old model. Um, but there's really not much this offers in way of external models. No, but again, when this thing was released, this was the absolute pinnacle of freeware for FSX. Freeware helicopter. Actually, I mean, even compared to some fixed wing models, this was the model to have. I mean, when they first announced it on Hover Control, I mean, I followed the development of this thing, and when I started doing modeling and developing on my own, I downloaded because they released the source files for it. This is a MSDS. It was created in MSDS, the Abacus product, and I downloaded the FSC file for it, and I learned a lot about uh, modeling flight sim helicopters from looking at how this one was built. So again, I know it's old, and but I'm not forgetting how good it was when it first released. Does it stand up to the X-Trident model for 3D modeling? No, no, it doesn't, and it shouldn't, because that would mean that you know flight simulation hasn't advanced since this model was first released, right? All right, and as far as sounds go, even if you're cranking up here, it's external sounds. They're not super realistic, but they're still pretty good. I mean, they're not so dynamic where like they change as you pan around it, but they're not bad. And they were great for their day. And it really doesn't sound. I mean, it doesn't sound like it's an exact recording of the 412, but it's believable for a 4-blade helicopter. But the sound, they're not fantastic, but they're not, at least they got it close to what a 4-bladed helicopter would sound like. So for graphic effects, this model doesn't come with anything that isn't already in, that's not already in FSX. So your dust from the rotor wash, that's pretty standard. So you can see there, if you hover across the grass, that's pretty much standard for any rotor. But, rotor wash is modeled here, so that's something that will help enhance the experience a little bit. And you get some, I mean, you don't get like any wind directions, like so if you have a lot of wind, the rotor wash doesn't like get pushed to one side or anything like that, because that really wasn't a priority for FSX. But you do get the same effects over water. And one of the things you actually notice as we're flying around here is the rotors disappear behind some of the other 3D models, like the buildings here. And that is a artifact of it coming from Microsoft 2004 Century Flight. All of the ported models have that issue versus the FSX pure models that typically don't. So here you can see the rotor wash effects over water. It's a different effect, different color, so it's still, so that's pretty neat. It's actually, these rotor effects look a little better than they do in the X-Plane, to be honest with you. As far as the ones over water, once an X-Plane looks like you're kicking up a bunch of cotton balls or something, that's just kind of dumb. So graphic effects, there's some, it's nothing that's really gonna like help you out during, sorry, it's really nothing that's gonna help you fly better. It's just sort of to enhance the overall experience. For special features, to be honest with you, when this thing first was released, it was the special feature, because there wasn't really a model for FSX like this. I mean, not for Microsoft Flight Simulator Century Flight. So for FS 2004, like this model was doing dual engine starts before dual engine starts were a thing in home use flight simulators. All right, so if we were making this video, 14 years ago, yeah, that would be a special feature. But now, there's not so much anymore, really, to be honest with you. So let's go over how this model did. So we're going to look at a couple of things here. So tallied up all the scores, and here's where we're sitting. So flight dynamics, and this is kind of where I expect. There's not a lot of surprises here. So for flight dynamics, we're below 200, and honestly, that's not really the developer's fault. It's just that, again, if we did this video 14, 15 years ago, this would probably be way up here because it would be better than what was available. But as far as coming close to what I imagine this aircraft should behave like, now granted, the 412 is, from what I understand, a very stable platform. So I'm not knocking it on its stability, but its cyclic response is just really sluggish, and the amount of cyclic displacement needed to get the aircraft to move the way we want it to, that was a real big factor. And then there are some other things that we saw. So we see a lot of zeros here. So like pedal input required. Now that could be because it was actually modeled with AP1 or HP1 and HP2 enabled. I'm not sure, but if it was, great. But to be fair to the X Trident model, I did that entire review or that entire evaluation with the HP1, HP2 disabled because we were testing the characteristics of the flight model, not the characteristics of the flight management system or the FMC or the whatever you want to call it, FLCS or AFCS. I don't know what they call it in this model. So, and max takeoff weight influence, torque and RPM influence, things like that. We just kept getting zeros on. RPM reaction, couldn't get that RPM to do anything no matter what we did. Needle separation, just some weird wonky stuff that probably wasn't even an issue or probably wasn't even possible when this thing was created. But again, we just could not get that RPM to do anything other than sit in the green unless we rolled the throttle off. And even then we got into some weird behavior. We started messing with the throttle. So see, we see a lot of zeros here, so that's not really a surprise why that's down there. Cockpit, it's an old model, but it did perform pretty well as far as that goes. Systems, not a surprise. Not a surprise at all, because it's an old model. Originally Flight Sim 2004, Century of Flight. Not a lot of systems could be modeled back then, so it stands to reason that it's still not there. User manual, freeware, not a surprise. So freeware typically isn't real user manual friendly. It usually just comes with a README file, to be honest with you. So I gave them more points because they included a checklist for that. So I mean, and it's so for a grand total, it's not super impressive, but it's a testament to this model is that it's 2019 and we're still looking at it because it is popular. People still like this model. So we felt it was necessary to put it to the test. So there you have it. That's the Hover Control Bell 412 for FSX. And I hope you enjoyed the video. So I'm sorry it was so long, but we got through it.